Nothing too terribly earth-shattering. Add a timestamp, basically, that gets updated every time you change the thing, and then sort by that. Who did it? Not too bad for the last day, but come on, guys. Come on. So we're already saving a timestamp on ID, right? Node ID equals date.now. So we just kind of do the same thing on a different field, only we do it whether it's a new or an existing node. We do it every time. So I'll do this. I'll set a variable up here. Where should I put it? Doesn't matter. Let's say const timestamp equals date.now. And I'll say note dot updated at equals timestamp. And then down here, I'll reuse that so we don't run date.now twice. Timestamp. So we only set the ID if it's a brand new node. But we set updated at every time we update a node, even after it's created. So that value will continue to change. So that's half of it right there. That just does it. We did it. We're finished. Fresh. Let's make a little tiny change to all of them. Look at our database. Now they've all got an updated at. Cool. It is the number of milliseconds since January 1st, 1970. Yeah. Because when designing Unix, that's how they decided to represent time. So a Unix epoch. So timestamps in a lot of systems, including anything Unix-based, they use milliseconds since January 1st, 1970. And so when you get a new time, that's what it is. I think it's milliseconds. Well, you can. Well, this was part of the Y2K issue. Was like it wasn't, except it wasn't Y2K. It was like sometime in 2016 that it would have been a problem if they hadn't fixed it. But like it wasn't a big enough number originally. It didn't have enough bytes in it to store dates beyond that. But they fixed it. Also, Y2K was, you guys were infants when that whole thing happened. But that was a good time. Anyway, so that's what that number is. There are libraries you can use to translate that into a human readable time. Moment.js is a good one. Moment. So if you wanted to actually like display this on the page, if you wanted to say last updated whatever or saved at whatever, you could use moment to turn that into, whatever, May 31st at 1:47 p.m. Eastern Standard Time or whatever, Eastern Daylight Time. So that's what that is. So now we want to sort by it, right? We could just sort every time we add a new one. Just resort the array before we update it in state. Wouldn't you know it? There's a function called array sort. So notes.sort. See what it says. Sorts an array. Takes an argument, which is a compare function, a callback. The name of the function used to determine the order of the elements. If omitted, the elements are stored in ascending ASCII character order. In other words, they're converted to a string and compared. So if we have an array, five, 17, 3, 20, 101, 6, and just call sort, didn't do what we expected, did it? This starts with a 1. So that's small, right? It converts them to a string and then it compares them. So if you wanted to do anything different than that, so if you have a couple of objects, so the notes are objects, right? Convert that to a string, it's going to be bracket, object, object, bracket. That's what that converted to a string is. So it has no idea how to compare those things. So we have to tell it how to compare those things. So we can pass a callback function. That didn't say bind. So we'll pass in a callback function, and it's going to pass 2 arguments into our function, typically called A and B. And what it does is it uses the return value of this function to compare the objects. So it'll take each thing from the array, and it will do whatever you say to do to them here. And it uses, if you return a negative value, it knows which one's bigger. If you return a 0, it knows they're equal. If it returns a positive number, it knows which one's bigger. So let's see this in action. So suppose I have this same array. I should have saved this to a variable. So let's do that. And I say r.sort, and I pass it my callback function, a and b, and I say return a minus b. That's all my callback function does. Then I get them in order. So say it compares 3 and 5. 3 minus 5 is a negative number, so it knows 5 is the bigger number. It knows b is bigger than a, so it knows how to sort that. If I did 20 minus 17, I'm going to get a positive number. So it knows the first number was bigger. It knows a is bigger than b. If they were the same, obviously I would get 0 when I try to subtract them. So that's basically how this callback function works. So what I need to do here is something like a dot updated at minus b dot updated at, and that would put them in order with the oldest first. But we want newest first, right? So it's b dot updated at minus a dot updated at. So to use our other array as an example, first of all, I need to reassign this because it actually saves it in place. There we go. Our unsorted array. We call it again, and I say b minus a instead of a minus b. I should get it sorted in the opposite order, right? Largest number first. Make sure I return that. And let's see what happens. Okay, that one's at the top. Now that one's at the top. Make a new one. New one's at the top. Make an update to an old one. It goes straight to the top. So whichever one you've worked on most recently is always at the top of the list, which happens to be how Evernote works, because they copied us. So that's it. That's all there is to it. Sort notes by time of last update. Questions? Yeah.
So when you're doing the sort and you have the function, so would it not work if you just used a greater than or less than?
Right. Right, it would not. Okay. Because it wants, it doesn't just need to know, is this greater than that? It needs to know if it's equal to, right? It needs to know all three things. Is it greater than, is it less than, or is it equal? So the easiest way to do that is to subtract them from each other and see if it's a negative number or a positive number or 0. So this is a fairly common thing in a lot of languages. There's actually an operator for that in Ruby. They call it the spaceship operator, like that.